Ideal molecular shapes. Let us use the same representative notation as earlier, A denoting the central atom and X denoting the terminal atoms. Also, we shall represent pairs of electrons on the central atom by bars on the sphere. Using this notation, we shall understand the 5 ideal molecular shapes according to VS-EPR theory. Ideal molecular shapes are attained only when bonding electron pairs are found on the central atom and no lone pair electrons are found. Linear shape. In molecule AX2, we observe that there are 2 bonding electron pairs. We can see how the electron pair repulsion pushes the bars apart. Repulsion is minimized when the bars attain a linear arrangement, where all 3 atoms are in a straight line. The angle formed by the atoms is 180 degrees in this case. Electron pairs can be single bonds, as in the case of BeCl2 and BeF2, double bonds, as in the case of CO2, or even triple bonds, as in the case of HCN. Trigonal planar. In molecule AX3, we can see 3 bonding electron pairs around the central atom. These electron pairs attain minimum repulsion when they are spread evenly around the central atom. This arrangement is called trigonal planar arrangement as 3, tri. Atoms are bonded to the central atom, and all 4 atoms lie in a single plane, planar. It has a bond angle of 120 degrees. We observe such an arrangement in molecules with 3 identical groups, such as BF3 and SO3.
Note that you do not have to be able to draw the Lewis diagram for SO3.
Tetrahedral. 4 bonding electron pairs around the central atom are seen in the molecule AX4. They attain minimum repulsion in the tetrahedral arrangement, where the terminal atoms position themselves on the vertices of a regular tetrahedron. This is called tetrahedral arrangement, as it has 4 faces, tetra meaning 4. This tetrahedral arrangement has a bond angle of 109.5 degrees. The tetrahedral shape is very common in organic molecules. As an example is methane, CH4, the simplest hydrocarbon. Trigonal bipyramidal. In the case of AX5, we have 5 electron pairs around a central atom. They will have minimum repulsions where they point to the corners of a trigonal bipyramid. We can recollect the trigonal planar, where tri was used for 3 atoms around the central atom in a triangular arrangement. We can see the same structure of those 3 terminal atoms here. The other 2 terminal atoms position themselves on opposite sides of this planar arrangement at the top and bottom, forming 2 pyramids. This gives us our bi, or 2, pyramidal structure. Here, we find 2 bond angles. The 3 terminal atoms in the trigonal plane lie 120 degrees apart, and the other 2 terminal atoms are at 90 degrees to the trigonal plane.
Phosphorus pentafluoride, PF5,
is an example of this molecular arrangement.
Note that you do not have to be able to draw a Lewis diagram for PF5.
Octahedral. The last ideal arrangement is in the case of AX6, which has 6 electron pairs around the central atom. Repulsion is minimized when the groups point to the corners of a regular octahedron, lying 90 degrees apart. 4 terminal atoms are in a plane, forming a square, while 2 other terminal atoms are on top and at the bottom of this plane. This arrangement is called octahedral arrangement, as it has 8 faces. Sulfur hexafluoride, SF6, has an octahedral shape.
Note that you do not have to be able to draw a Lewis diagram for SF6.
It is important to note carefully that these ideal shapes exist only when no lone pairs of electrons are present around the central atom. Let us look at the 5 ideal molecular shapes again.
Starting to feel it? Now go master it with Maski.